Right, this is my latest acquisition. It's an Intel SDK-85, which stands for System Design Kit. It was marketed by Intel to sort of showcase their new SDK-85 processor, which was launched in 1976. I'm not sure how old this board is. The manual says 77, so probably somewhere around that area. It's quite an interesting processor. It is here. Only 40 pins, but they squeezed a lot into that 40 pins. Its instruction set is actually 100% compatible with the 8080, and you can run 8080 code on it. All it's got is 2 additional instructions, SID and SOD, which stands for serial input data and serial output data, because 2 of these pins, not sure which one, are used for serial input and serial output. The way they compressed so much into 40 pins, they multiplexed the lower 8 address bits with the data bus. So if you don't use MCS85 compatible chips, then you need to actually latch those address bits while you're reading and writing data. They actually had their own latch for that, which would have gone up here as an 8212. But if you use the MCS85 chips, then that's all taken care of for you. So that's a sort of brief overview. The other good thing about it, compared to the 8080, it's got the clock generator built into it as well. As you can see, there's very little here. See the crystals there, and the crystal actually attaches directly to the processor. So you could have a very, very small system. In this particular system, I mean, if we ignore this bit here, we'll go over that in a minute, you could actually build a system with your processor, a crystal, this 8355, which is a 2K ROM with 2 8-bit output ports on it, and if you want some RAM, that sort of sits down here. That was an 8155 that contained 256 bytes of RAM, 2 8-bit ports and 1 6-bit port. So with those 3 chips and an address decoder, you've got a complete system there. So it's really neat. So not only could you use the 8085 in a much bigger system, as we've seen in the IPDS, which actually had 2 8085 processors in it, if you remember, and it could actually have 3 in with the optional second processor. Also, it found its way into the MDS2 series and 3, and also as a ISIS execution unit in the MDS4. So it was certainly in a lot of Intel products. I'm not sure how far it went beyond that. Unfortunately, a lot of the sort of CPM systems of the time, they either still use the 8080 or very often the Z80. So quite how far the 8085 went, I'm not quite sure, but it is a really versatile processor, especially if you want to use it in its sort of microcontroller mode like it is here. Okay, right, we'll have a look at the various bits on this board next. Right, so to make this work, you don't need very many components, as I mentioned earlier. You don't need the stuff in this corner, that's for a teletype up interface, but we do need most of the stuff down here. So we've got keyboard and LED display, got the transistors to drive the LEDs. There should be I think it's a 74156 scan decoder for the keyboard and the display. It should be in there, so that's missing. This is a 8279, which is a part of the MCS85 family. That drives the LEDs and reads the keyboard. There's a 3205 probably address decoder there, just to decode the memory for the ROM and the RAM. We've got the 8085 processor itself, and this one's got an 8355 master programmed ROM in it. You could put an 8755 in there, which we may have to do if this is wrecked, because I've not powered this up yet, so there could be all sorts of things wrong with it. The RAM chip's missing, got a new one of those. That's an 8155, 256 bytes. So that's all you need, just that little chunk there. So you see it does make quite a useful little microcontroller. I think that's about it. What we'll do next, let's have a little look over the board and see what sort of a state it's in. I think the kit was actually a kit. I don't think it was ever supplied as a sort of completed device. I think the person that put this together didn't do a bad job of the sort of main soldering, to be honest. But that really can't be said for the person who actually used it. I don't know if you can see, I don't know how well it will come out on the camera, but if you can see the sort of horror of the soldering there, it's pretty bad. And it's there's some more of it there, which isn't very pleasant. We've got this wire here that's just sort of floating about in space. Not sure what that's doing either, to be honest. That's going to have to go. Again, if you look at this wiring here, this wiring is on the I/O port of the RAM chip, because the RAM chip and the ROM chip both have I/O on them, as I mentioned earlier. But I'm not sure you can actually see how bad this is. What I'll do is, if it doesn't come out too well on the camera, I'll put some pictures up so you can appreciate the true horror of it. It's pretty much, well, some of the worst soldering I've seen, to be honest. This is the port on the ROM. I mean, this may well be why the RAM chip's missing. It may be after all that horrendous wiring down here, it's destroyed the RAM chip. What else did I notice? Oh, we seem to have up the top here, seem to have an attempt at some sort of power supply reversal avoidance here. A couple of diodes. That's interesting. So that's about it. That's about the state of it at the moment. Oh look, hang on, there's another wire up here, look. This one's just hanging off. I don't think that's even soldered, look. It's just spinning round. I bet there's no solder on the back of that, is there? Actually see it? I can't actually see it, but I think it might even pull out. No, I can't get it out, but I'm amazed that isn't just falling out of the board, to be honest. It's pretty ropey. Anyway, that's the quality of the soldering we're dealing with. So what I'll do, I won't do it on camera, obviously, because some of this is going to be quite delicate. But what I'll do, I'll try and remove all this crap here, clean it up, and then we'll take out all the chips so we don't damage anything, power it up, make sure there's no shorts in it, and then we'll see how we go from there. And hopefully at some point we can get it working. There is the code for the ROM in this published, so that's not a problem. Plus I've got my own monitor for one of these, so if the worst comes to the worst and this ROM is destroyed, we can put an 8755 in there. I've got a programmer for that. Mind you, having said that, I haven't got an 8755, so you may have to wait a little while to get that, but we'll see how we go. Hopefully the ROM's still alright. I'm not convinced that its I/O ports will be okay though, not looking at the wiring there, so we'll just have to see, I guess. Right, let me get on with it and I'll see you in a little bit. Right, well, after about 2.5 hours work, I've managed to clean it all up. I've actually been over the back as well, gave it a bit of a scrub with some IPA and a toothbrush, so it looks a little bit better now. Unfortunately, I have lost a couple of pads. I mean, that was almost inevitable, really. You might be able to see them just there. So those 2 pads have gone. I can probably repair that. The other one as well, which is really strange, this track here, I don't know if you can see it, it seems to have vaporised. I don't know where it's gone. It seems to have been cut off there and it's just vanished. It just doesn't go up to the pin up there, so that's all a bit strange. A lot of the holes were completely blocked with bits of snapped off wire, so that took ages. I had to heat up a pin and sort of push down on it to get the bits of broken wire out. Cleaned up a bit at the top here. There was a few bits of wire there, and that red and green wire have gone on the back now. The ones that were down here, and so I've cleaned the back, so it looks a little bit better. There's that's the back side. You can see where the board's been burnt a bit, so there's not much you can do. And same on the one there. What I've done, I've actually cut up a couple of headers. So I've got that one and that one. So what I'll do, I'll repair the track and then I'll pop those in the board. Oops, probably not like that. So once they've gone in there, that'll sort of tidy it up a bit, hopefully. Right, so that's that. Right, so the next stage is to sort of start thinking about powering it up. But what we really need to do is make sure it's not shorted. So I'll bring the meter in there, and then we'll clip onto the power leads and see what we've got. Right, that doesn't look too bad, does it? 3.5 meg. I'm sure that's not going to be a problem. It's always worth reversing the meter leads as well, because it gives you a good sort of check on the capacitors, because you can usually see them charging up if they're actually working. Let's just click that on there. Now on the meter. You see, you can actually see a sort of discharge on the capacitor because we've charged it up in the opposite direction, having the leads the other way around. So the chances are that electrolytic there is probably actually working. Right, so that looks hopeful. Nothing nasty anyway. So what we'll do, we'll put some power on it now and see what happens. Right, let me just get the power supply in. Right, okay, set up. Looks like my power supply doesn't agree with the camera too much. Sort of strange scanning on the display. I've got it set to 5 volt and 300 milliamps, just as a limit. Not expecting it to draw very much current. Well, I'm hoping there isn't going to be. Right, let's turn it on, see what happens. Right, there you go. It's actually reading 0, so we haven't got any shorts there. And our little capacitor up the top there obviously must be fairly happy. If you were sort of putting a bit more voltage on, I'd be inclined to sort of wind the voltage up very gradually, but at 5 volt it's not really going to be much of a problem. Once you get in the 12 volt region and it's worth something that hasn't been powered up from a long time, you know, just wind the voltage up very gradually and that'll allow the capacitors to reform. Right, so that looks hopeful. One thing I didn't show you, hang on a sec. I took this IC out, if you can see the legs, right a state, and that's how I pulled it out. That wasn't, I didn't bend it as I pulled it out. That was the decoder that goes in there. So that was interesting. Right, so what we'll do is I'll put the chips in, and then we'll power it up and see what happens. Right, I've got all the chips back in. One thing I have noticed is that this isn't an Intel 8085, it's an NEC one, so clearly that's not the original. And also, this isn't a 3205 either. It's a 138, but yeah, or sorry, 74LS138, which is the TTL equivalent of 3205, so that's not original either. So that's intriguing. So anyway, I've reset the supply to a maximum of 1.5 amps. It shouldn't draw anywhere near that, I wouldn't have thought. So let's give it a try. We'll power it up, see what happens. Alright, okay, that doesn't look good. It is actually drawing 1.5 amps, and we've got an 8 on the display there, which isn't a good sign. Alright, so a little feel round and see if anything's getting warm. Oh yeah, that's not good. 8085 is really baking. Right, there's something horribly wrong there. Let's turn that off before it goes up in smoke. Right, I think we need to change that 8085 out. Right, hang on a sec. Right, I've got a genuine Intel 8085 in there now, so we have a little bit more luck. Right, let's hit the power button. Oh, that looks better. I've actually got 8085 on the display now. Let's do a quick reset, make sure that goes in. Oh, that looks a lot better. Right, let's just do a little check of RAM. So if we do substitute memory, I think the RAM's at 2000, so let me just put in 0, 1, 2, 3, 0, 4. Right, reset. Right, there we go, RAM's working. Right, that looks hopeful. Let's try doing a quick go. If we do go 0, that's its reset vector, so that should just reset it, which it does. I'm about to do a little single step maybe. See it bouncing through its code there. Oh, that looks okay. Right, that looks good then. Right, so the only let's just have a look, see if everything's cool now. We're drawing a lot less current, not only about 450 milliamps, which is a lot better than it was before. Oh yeah, everything's pretty cool now. Oh, that's much better, isn't it? Right. Okay. So the remaining question is, are the ports wrecked on our ROM chip? So what I'll do, I'll get the logic probe out, and then we'll write a little program and check the ports, see if they're still intact. But looking hopeful. Just do a quick on and off cycle on it. Yeah, looks fine. Okay. Right, I've set up a simple program that just rotates a bit through the accumulator and outputs it to the ports on the ROM chip. I've dimmed the lights a bit so you can see the logic probe a little bit more clearly, hopefully. It's just at the point now where it's zeroed port A. So we go 1, 2, 3, 4, 5, 6, 7, 8. See, they're all 0. So what I'll do, I'll start on bit 0. If we start running the program, we should see that go high, which we do. Move on to the next bit. That one goes high. 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 Again. Right, that's bit 8. Right, so let's go back to the beginning, and if I do that, it'll just rotate round again. There you go. Right, so that's that port. Now I just need to alter the numbers for the second port. So reset, and I need to change 2008 to reflect port 1. And I need to change 2000B, which I've just gone straight past. Okay, let's try that again. Right, change that to 01. Reset, single step. Alright, hopefully should be on the next port now. Everything should be 0 again, like it was on the other one. 0, 0, 0, 0, 0. Right, so we'll sit on port, bit 0 and wait for that to change to a 1, which it does. That's the next bit. Next bit. Okay, it's through. It's gone through. It's gone through. Okay, this is the last bit. It should go back to the beginning again now, which it does. So the ports are working. The only thing that's worrying me is, let's just stay on this port for a minute. And when I reset, you notice there's a sort of dim glow on the logic probe, which means it's sort of tri-stated. That's because it should go to an input when you do a reset, which this one has. But if you look at the bottom bit here, look, it's high. If I hold the reset down, it's an input. And yeah, as soon as I release the reset button, it seems to go back to an output, which seems a bit strange. I'm going to have to do a little bit more investigation on that. So it's possible there are still problems with that, the I/O on that ROM chip. I'm hardly surprised after seeing the horrendous soldering. So I'll have a little think about that, and then if we do another video on this, I'll give you an update. But anyway, that'll do it for this one. If you enjoyed the video, please give me a thumbs up, and I'll see you next time.